All right, it's Thursday. So let's walk through this. Um, so if you remember, this class follows kind of a 2 week cycle. Um, we do some things every week, but every 2 weeks we have a bigger project and a little more work to do. And so this is week two. So that means this week we have a little more work to do than uh, an odd week like next week. We'll have a little less there. Um, I also, I think, lied to you at some point. I think I told you that discussions were due every 2 weeks there, and I thought, and I already last week I set the discussion for week unit one due uh, this Sunday, but that was a lie. Oh, well, it was. But we will do discussions, new discussions every unit. Every week we'll have a new discussion topic. So if you didn't do the discussions from unit one last week, you still have to do them, and they're still not due until Sunday. So you still have time. But going forward, discussions will always be due that week, that Sunday night for this. So again, every week we will have an explore activity. Again, this is an external tutorial that you can work through here. We'll have a learning notebook that we'll walk through on Thursday. So this is Thursday. We'll walk through this today. And then your discussion, some discussion topic that you'll do post. And again, usually you will have to do at least 2 posts here. So you can do, and again, they can be original posts or replies here, but at least two. So you can do 2 original posts, you can do 2 replies, you can do an original post and a reply, any combination of those for those. And then every 2 weeks, we'll have this larger project due. Now, like today, we'll walk through the learning activity, and that will set up a lot of the stuff for doing the project. So we'll actually talk about parts of the project as we're doing the learning activity. Now, you can complete the project without the learning or before the learning activity on Thursday, that sort of stuff. But and particularly if you have some experience with computing and maybe programming and stuff, that will be easier. But again, for some of you who don't have as much experience, who like, you know, haven't worked in this area very much, the learning activity on Thursday here will often walk us through the same topics as we did. And then on, again, Tuesday, we actually do some resources. So like on Tuesday, we went over this data cleaning and visualization collab as an example. And we'll do the same sort of stuff today in the learning activity for this. So, again, today we'll walk through this learning activity. The goal is that by the end of the day, you have finished Learning Notebook 2 and are ready to submit that. There's a write-up that goes with it here. And so again, hopefully it's not due until Sunday, but again, we'll try to get it all done today in the class period. And as we're going through that, we'll also talk about this breast cancer project and this visualization project. So I'm just going to open up the Learning Activity 2 notebook and start working through that. So you'll want to make a copy of this here. And you also will have this write-up. So you want to open up the write-up and make a copy of the write-up here. But again, you can paste the links back and forth if you want, or submit each link. Eventually, you have to submit both of these in for this project. So I'm just going to open up this learning activity. Oh, we get to do the iris flower stuff. Oh, I love that. You just saw so many fond memories as a data person with iris flowers. So there's this long standing, I don't know if you know, in programming world, there's the first program you often do is called a hello world program in any language. You print out hello world in the language when you're writing your first thing. And iris flowers are kind of like the hello world of the data analytics world. It is kind of the first data set a lot of people work with, and we use it in a lot of problems here. I don't know why, I don't know where it comes from, but if you look online, there are hundreds of examples and stuff, people doing that, working with this the same iris data set. So this is I think this is the first time you've seen it. So let's talk a little bit about it. Yes, we'll be talking about it a lot in the next 4 weeks, I think, before we get away from this. So these are iris flowers. There are 3 species: Iris setosa, Iris virginica, Iris versicolor here. Now, if you look at these flowers, they have these larger petals and these smaller things we call sepals. And so to classify these, we are going to do some measurements. We're going to measure the length of the petal and the width of the petal. And we're going to measure the length of a sepal and the width of a sepal. So that's going to give us 4 measurements for every flower. And with that, with those 4 measurements, we'll try to classify a flower. So if someone goes out in the field, you find a flower, you just do measure, do these 4 measurements, and then we should be able to then hopefully tell you what kind of flower this is. So this is the data set for this. So now we're going in here, again, we are running this, we're importing our libraries, we're reading in this data. I'll just note that there's actually official versions of this data. We are not using this. We are using Tom's modified version of the data. So I have gone in and put in some errors in this data that we're going to have to correct. So there are some problems that I've introduced into this data that aren't in the normal data set here. Okay, so we bring in the data. And again, we're going to try to look at this data. So we're going to use this. So what is the data called? We are reading it into a data frame called iris. So iris is our data frame. So if we want to display it, we would say iris.head, parentheses 5, to display 5 items here. If we want to do tail, we would do iris tail. So if you remember, there's these commands. There's different ways of specifying. You can say iris.head, parenthesis, just iris.head. You can just say iris. And again, remember, we can comment and uncomment this stuff, these commands out. So if we want to try one of these, if I just want to try iris, this is what iris prints out. And notice there are 4 different measurements, all in centimeters: sepal length, sepal width, petal length, petal width. So every flower has these 4 measurements, and then the species. And again, there's Iris setosa, Iris virginica, Iris versicolor for these. Also in there, every flower has an ID number as its index in this example. Yeah, and we can print it out. We can try different things. Remember, and again, we don't really have to use, we can use this ilock command to select certain columns and certain rows for this. We can just select certain rows for this. There's different ways we can manipulate this data. This is another way, as if we just want to select a column, we can say iris bracket, excuse me, quote, single quote, and then the name of the column here. So let's see if in our write-up you have to do anything. So again, we're using data frames. Data frames are a way of storing data. You research a data frame and write what it is and write a paragraph describing it here. I'm fine if you use AI in this case to write this paragraph in these learning activities and stuff like that. So you can ask AI, you can just Google it or whatever. And again, if you're using a source or AI, just cite it for this. So you can put this. Now, the following Python commands display data in similar ways. In the Colab, try out each of these commands and describe what it does. So again, we've got this data here. And again, I think there's this, like this one has all three. So I can just comment one out. And again, they'll all be very similar. Let's see. So Iris had 10 is the first one. And again, you have to do this as long as you do this in section 1 after we've imported our data here. You can actually just add, if you can't find this, you can add just a code cell and paste this code in here too. So Iris had 10. So just go through and try out each of these commands and then just write afterwards a quick summary. You know, Iris had 10. What does that do? So, I mean, it displays the first 10 rows. So you can just write that. Displays first 10 rows. So I'll give you a chance to work through these first questions, unit or task 1 questions, where we're just kind of trying to explore, look at, manage this data set. And just remember, you're always, the data frame is called Iris in this case. You Iris dot something. These learning activities, oh, question? Sure. So weird, one of the students is asking, this Iris had without a 5 or anything there, that seems to be giving an error here. So I'm just gonna run that again. So yeah, it's giving me an error here. One of the problems with this class is that the Python language is changing, especially these libraries, NumPy and stuff like that. So every class, what I try to do is make sure I run these things. So I've actually run this whole thing. And there was actually an error, this bottom stuff, there was an error here in how correlation matrices were done with one of the more recent updates, and so I had to fix that. I didn't catch this Iris had. So it looks like you can no longer just say Iris had by itself, right? You're getting an error. So just write that it gives you an error there, where Iris had, I think you have to specify a 5 there, right?
You scroll down, it still say the default and it's 5.
Yeah.
So I didn't display it. So.
But why didn't it display it there? I'm just wondering why it didn't. Oh, what if I said Iris had, oops, and just put parentheses? That work? Yeah. Okay. If you just say Iris had paren without anything in it, then it'll default to 5 out there. Again, it used to be you could just say, I think Iris had without anything there. So another thing, so these are just learning activities in class. And so the idea is just to make you do stuff to learn. So I'm fine with however you learn. So if you want to ask me, if you want to share results, if you want to post results, if you want to, do that. If you want to use AI for these learning activities, any of that is generally fine there. So for example, if I go in here, I'm just going to, this 1.4, I'm going to give at least 2 different commands to display the column sepal length from a data frame. And I'm going, I don't know what that means. So I'm just going to paste that into AI here. And it's going to, this generates some examples, data frame.sepal length. But make sure you try these out. If I take this, and again, you might have to give it a little better instruction. Take that and put it back in my code here. I'm going to make a new code cell and just paste that in. It's going to give me this error for this. So I could go back here and try to ask it or say, oh, my data frame is called iris. So it really should be iris here. But you can also ask AI here to explain this error for this, and it will run AI and try to look at this. And let's see if it catches. And no, so it actually gets the right thing. It says, oh, DF is not your data frame, iris is. So again, the Gemini that's built in, the AI that's built in here will sometimes give you pretty good results here also. So I'm going to comment this one out and put this one in, and that should be right. So again, feel free to use AI. Again, you can use ChatGPT or some other AI here, although sometimes it, make sure you test what it tells you. It's not always right. And then also you can use the built-in AI in this notebook, this Gemini, or whenever you get an error, you click on it and see what it says. Okay, I'll stop talking again. So if some of you are getting to part 2, I'll just talk a little bit about that. So section 1 is just kind of like manipulating the data, but it's just kind of for play or make sure we're kind of used to that sort of stuff. Section 2 is when we're actually going to be looking at the data, looking for anomalies and cleaning up the data, removing anomalies and stuff like that here. We first just start to look at how many rows and columns are in this data. And again, we can actually kind of see that here. You can, when you display your data, 1, 2, 3, 4, 5 columns, and how many rows. There's 150 rows, it looks like, when I do a tail for this. But again, sometimes that's hard to see. So we can also just run this shape command. This will show there's 151 rows and 5 columns here. And again, here's another view of it. And here's just iris.info parenthesis. That displays this, and it says, there are 151 entries, from 1 to 150, and there's a total of 5 columns. And here are the 5 columns, and it tells you how many non-null items there are. And you notice that there's 151 here, 151 here, but here there are only 150 non-null. So for petal length, there are only 150 non-null items, and here there's only 150. So it looks like there are some null values in here. So we can look, we have 151 sepal measurements, but only 150 petal measurements. So that means that there's some null values in the petal, both of the petal values, it looks like. We can also do things like count how many of the different ones we're seeing. So we have, again, we are counting, we have 50 Setosa, 50 versicolor, 50 virginica, and 1 missing data one for this. So we're going to want to eventually remove or find the ones that are null or missing here. And there's different ways of doing this, but here's one command. We can say, find all the irises where it's null on any of the axes, and then update it. And this will just show us the null one here. We can also look at the largest here. And then in section 3, we start talking about removing these values, dropping the null ones. There's a command called drop NA. Now, there's not a whole lot you have to do in here. I mean, the code is largely all here, but you have to go through the write-up and talk about what's happening here. But this also should be preparing you for your project. So if I look at the project works with a different data set called the Wisconsin Breast Cancer data set. And again, we import it in section 0 and read it all in, and we do a display here. It has like 31 columns and a bunch of rows. And you have to clean up the data. But here's the code for that I give you for cleaning up the data. I don't give you any code for cleaning up the data. It's all empty cells here. So you've got to put code here for cleaning up the data. Similarly, here in the learning activity, I walk you through, ask you lots of questions like, what does this drop NA do? Why are we saving it here? Where in the write-up, I simply ask you to describe which rows you deleted, how you cleaned up the data, write a paragraph and clean up the data here. And you put it in your code here. So you got to practice things like, this is the command for dropping the null ones. I'm going to copy that over here and do that here. So I'm going to paste it in here now. This isn't going to work right away because in this area, my data set is called cancer, not iris. So if I say iris.drop_NA, there's no iris. That's going to give me an error. So actually, AI is actually catching this and trying to stop me from doing this. So if I just try to do iris.clean here, it's going to give me an error and tell me iris, name iris not defined. So I can't just copy this code. I have to realize what it's doing, that this is the data frame. And my data frame over here is called, what is it called? It is just called like cancer.head. So I want to do the same thing, cancer.drop_NA. And I'm going to save it in a new variable. And in the other one, I called it iris clean. Here I could call it iris clean. It wouldn't really make very much sense. I should call it maybe cancer clean or something like that. And again, when I pasted this code in here, AI caught it and said, oh, it looks like that's wrong. So it caught part of it, but not all of the error here. But again, I probably want to do something like a cancer clean equals cancer.drop_NA and do something like that. Okay, so you can decide or pay attention while you're doing this learning practice activity. You'll want to be doing eventually, you want to do the same thing in the project here. Now, also know that I know, especially when we get started here, often you get stuck with things. And so we find that working in pairs helps. So you're assigned a pair for the project here. So you're assigned a partner in crime here. So this is our partner assignments here for this. You can decide how you want to work with your partner here. You can just do question answer, like if you get each work on it kind of your own, and when you get stuck, just ask your partner for help. You can use ping pong, have one person do one section, maybe turn it over, have the other person do the other section. You can work on it in class synchronous. If you want to just sit down next to your partner, you can do that. Here, you can decide how you want to work on it.
My primary got for it.
Well, that's good. So that will simplify your partner activity in some ways. So I think I'll see if we have if I know of anyone else who dropped the course. Right now I don't know. I haven't said so. Yes. So but yeah, I'll simplify that for you. So, right. So, okay, I'll let you get back to this stuff. Yes.
Is it like you and your partner working on the same document, or are you just working alongside?
Again, you can decide. You can decide either way. If you're just going to ask questions and answer, you can each have your own document and work on it there. If you want to say, like, I'll do this section, you do that section, then you just create a shared document. I'm fine with that for that. So either way, for that. So, um, and again, one thing I want to avoid is this. So I always think of this Book of Mormon. I don't know if you listen to Book of Mormon very much, but
Students with ADHD
yeah.
save 10 hours studying with this Chrome extension.
No, by all. Now it's our time.
So in the Book of Mormon, they've just been assigned teams, partners to work with. So here's Kevin's response to that.
But mostly me.
So the whole song is you and me, but mostly me, here. And again, that is not the best way of doing things. That's why it's in a comedy musical there. So you can certainly do it that way. You can do you and me, but mostly me. And that's just fine. And you'll get full points. But you just realize that they have made whole songs about that, how funny that is. So it's a really funny song, though, I think. So. Okay, I'll be quiet again. I'll try. So I'm going to talk a little bit about finding anonymous, erroneous or abnormal values in here. So there are some commands like that we can talk about with our iris data. We can do like n largest will display the largest 10 values, but we have to specify which column. So we have to look at one column. So if we look at iris here dot n largest, and we can say 10, and then this stuff, it'll display. And what we want to look at is something that really stands out as an error here. So like here, we're looking at the sepal length here, and the sepal length here is they're all in the sevens here. These are the largest ones, so some of the other ones are much smaller, but again, 7. Now, 7.6, 7.7, there's a 7.9. You might think that's kind of large, but then there's a 48 here. So this is a 48 centimeter iris flower. So again, that'll be 4 meters, half a meter across, right? For that. And so that's good. That doesn't sound possible. So again, that seems really abnormal. We probably want to remove that one here. Another way of looking at it is to graph it here. Well, here's our plot command where we're showing this, and you can see a couple of these values that, here's all the values down here, all these lines, and here's this one flower that's way up here. That certainly seems strange for that. Now, you can actually talk about standard deviations to do a little better analysis if you want. So under the bonus area here, we do these what are called box plots of this data for this. And this shows like the iris setosa, where their values are, the iris versicolor, and the iris virginica. Generally the brown box is 1 standard deviation away. The lines, I believe, are 3 standard deviations away. So most things should be within the lines, but every once in a while you have something just outside the lines, that 1 in 100 flower, that's okay. That'll be outside the lines. But again, I would delete this one. Now, notice this dot way off to the right, floating way off there in space. That's part of this one. So here's all the other ones for that, and here's this one. That's the 40. All these are down here, and this is the 40 out here or whatever. This is the anomaly. Nothing here is really that anonymous, abnormal. But this one is. This is the one we want to get rid of for this. And again, you want to be doing the same thing for your cancer data eventually. So again, how would you, copy those commands. So again, this is like a command here. I could copy that over here and paste it in here. Try to run it. It's going to give me a couple errors here. One is you always have to watch the data frame here. Now, I generally start, I started with a data frame called iris. And then when I started to clean it up, I moved it to a copy called iris_clean. Now you don't have to, you can use iris throughout, but just I'm aware of that here. And that's what I suggest you do, is that when you start cleaning up your data, you make a copy of it. Here, I haven't done that, but and it should be called cancer. So I could just say cancer.nlargest and run that. But in a cancer, there are no flower petals there. So there's no sepal length here. So I have to make sure I change that to one of the columns here. So maybe I'll just do radius mean here. So I have to do that. And again, a lot of these are case sensitive. So I often copy and paste to make sure I get it in there right. So this will show the radius mean. And again, hopefully you'll see, so all the radius means are 23, 24, 25, 27, 28. That seems kind of big, but again, not that big. 1,343, that really seems like it's an anonymous, an abnormal reading, you know, so probably that had to be a typo. Maybe, you know, it was 13.43. Because that makes me think, because this is 00 afterwards. I'm thinking they just thought I missed a decimal place or something like that in this. And I'm not going to change it. I'm just going to get rid of it here. So again, that's what you want to do. And again, you can look through here. Now, once we found these, we want to remove these commands. And so there are ways of removing a command at a certain spot, or removing all of them where like the value is less than some value, or you want to just keep. Here we want to just keep only iris flowers, iris clean versions where the sepal length is less than some value. So there are some commands like this that you can run and try out. Okay, and then again, just remember to be working in your write-up as you're doing that. Questions on this? It should be very, if you're asking myself, should I remove this value or not? You probably shouldn't remove it. If you're saying, wow, that should be removed, then you should. Most of this data is very clear. What, you know, again, we're not removing just 1 in 100 things. We're removing data entry error sort of stuff, things like that. Eventually we want to get down to some visualization. So I just want to talk a little bit about visualization and bad data and how they're related. So like in your iris data, if you go down here and just run the first scatter plot and you don't clean up your data very well, it'll look something like this. All the data will be down here, and this is our one very bad data spot up here, data item. When we remove that, so this is the original cancer data I'm plotting. And then I have a clean version. So if I do this with my clean version, I have removed it. This is the same data as this. But again, we've removed this one item here. And so it looks a lot different. This is a lot better kind of view of it. So often, again, if your graphs are looking really strange, that might mean there's some bad data. Like here, with the cancer data, I'm just plotting the texture mean here. And it should not look like this here. It should look like this bunch of things where I can see the standard deviation. I know what that graph is. And this this one really bad data spot is showing up wrong. So I'm going to remove, if I remove that and get down here, then this is a better plot. Now, it also shows me that now this one looks bad too. There actually looks like there's a negative value here. I couldn't see that before because it was so skewed, but now I can see that. Now, again, you don't have to worry about things that are relatively close here. So if you're looking at this and going, you know, there's these values that are more than a standard deviation away or something like that. And again, with tumors and stuff, some of them are just strange. So again, I'm saying most of this, now this one I might want to look at a little bit, but you know, once I remove this, does this look like it's really out of the bounds or not? And maybe look at that data. But generally, again, if you're questioning it, you should keep the data. Like this, you know, if it's the size is -20, that's obviously wrong. So then I would remove that. So, and again, once we clean that up, your graphs should look better. So again, if your graphs are looking weird like this, try to make, you know, again, part of this is why we're doing visualization with the data cleaning is that they go hand in hand. The visualization will help you see sometimes the bad data, and then removing the bad data will help improve your visualization. So. So I've been asked twice now about like here where you're doing some of the visualization and what the change is. And what we want to do is with these plots, you can try different things like this is what is called a scatter plot. And we're doing two attributes, petal length to sepal width here. And we could swap those two out. In the iris data, we have 4. We have sepal width, sepal length, petal width. So I could try a different one here and do it. So I could do petal length to like petal width as a change, and then try to run that. In fact, most of these will actually show that this one shows that down here as an alternative. And again, I can do another one for that here. So again, try different ones. You only have 4 different values here, and you can just swap which ones you're kind of plotting to see. Now, when you get to the breast cancer visualizations and try that, in breast cancer, we have, 31 different attributes. So there's a lot more to choose from with breast cancer. Okay, did that answer? Okay, I'm going to break in one more time here, talk a little bit about some of the meaning that you can get from these visualizations. So again, why are we doing these models? We're usually trying to determine things like the iris data. We're going to try to want to have a model that would tell us which flower is which takes the measurements, predict which flower it is. And if we can see that in our visualization, our model should be able to capture that also. So like here, the blue ones, iris setosas in this example, are quite distinct from the rest of them out here. So that's a good division. You can actually see, almost draw a line here that would divide one from the other. But again, the orange and the green ones here, they're all intermingled. There's no way here, if we're looking at this, that we could, if I said there's a flower that's here, you wouldn't know what it was because there's a bunch of greens and a bunch of oranges, a bunch of versicolor, a bunch of virginicas combined here. Now, if we plotted some different examples like this, we're plotting 2 different characteristics. Again, our iris setosas, our blue ones are way down here, easy to divide out. But now I've got a pretty good division here between the greens and the oranges. There's a little overlap, but again, I can get 90% of them by drawing a division or a line kind of through here. And a model would be able to do that also. So again, this would be a better, set of attributes to look at, or more useful attributes than something like this where they're all intermingled as far as the model goes. Now, sometimes like this one, it's like scatter plot showing it in different colors, which is kind of helpful, but it doesn't always show it that way. Different plots will show different ways here. For example, here we showed it, the three species, with this sort of thing, each on its own graph, and we can kind of see overlap. So if we just look at petal length here, we could see anytime the petal length is like 2.3 or less, it's got to be an iris setosite if it's above that. And again, if it's below 4, it's largely this. If it's above 5, it's largely this one. There's a whole area of mixed ones here where it's not uncommon. And again, we can look at this. So like here, I'm looking at cancer diagnosis, and I'm looking at the texture mean. And there's a lot of overlap. Texture mean is probably not going to be that useful here, because again, this is a malignant tumors, and the texture means go from like 15, and some of them are even less, all the way up to 35. And then again, for benign, it's going from like 10 all the way up to almost 30, 35. So there, if I just knew that the texture mean was some value, like if it was like 25, I would say, looks like it's probably cancerous, but it could maybe not be cancerous there. We'd rather have these in, distinct attributes. So again, some of the graphs will show that distinction in different ways, but that's something you can use to judge these graphs is, does it, if you show the distinction, does it, break up the classes or whatever you're looking at nicely? Okay, I'm going to wrap up here and stop.